In this video, I'm talking about the GCSE Science course, the core course in the 21st Century Science suite. In many ways, perhaps it's the course within the suite which is most distinctively different from many previous science courses. It's designed primarily as a course to enhance the scientific literacy of all students, to give them the tools and the ideas that they need to engage with science in the ways that they will meet it in everyday life, either now or in the future, but outside the classroom. So it's not science for scientists, it's science for everybody, including scientists, but many people who will go on to non-scientific careers and will simply want to know science in the context of ordinary everyday life. Only a minority of us actually do become research scientists, but everybody meets science in so many forms that we all need some understanding of it to deal with it as we encounter it. Another way of putting that is to say that research scientists are producers of new scientific knowledge, but most of us are consumers of scientific ideas and scientific claims. They come to us through the media, through newspapers, television, and we have to decide how seriously to take them, whether to act on them, what to make of them. And this course is intended to provide you with the background understanding and the ideas about how science itself works that enable you to be a more intelligent, a better informed consumer of scientific ideas and information.
This year when we had the Spartan story, some of them are quite shocked and they've stopped drinking certain things. So some of them they responded to. Other bits they were quite shocked at some of the politics behind some of the decisions, and it was good for them to start questioning themselves as citizens. How are decisions made and who is controlling what goes on, whether it's the Food Standards Agency or anything else.
One of the things you clearly need is some basic scientific understanding. So the course does try to teach some of the big ideas of science, concentrating on ideas which seem to be important for understanding a range of issues, both those which come up now and those which might come up in the future.
So the ideas about science are a body of knowledge which describe how we know what we know. For example, students may learn about the limitations of data in IS1 and peer review from IS4. And they would then use this knowledge of ideas about science when they were critically evaluating sources for a case study. So the critical evaluation is a skill which draws on their knowledge of ideas about science.
When they began to do their case study, they kind of brought everything together and they started to realise the importance of science, its applications, and just based on the general how science works and how important it is to be able to talk about science and evaluate information about science.
So we try to teach them an understanding of data, the limitations of data, how to think about arguments about causes and correlations between factors and outcomes, how to think about the difference between the data and the explanation.
It's interesting to see just how hard they find it to actually see the difference between an observation and an explanation. So like, for example, you've got in your P1, your earth sciences, you have folded rocks and oldest rocks. Which one's an observation and explanation? Which seems very obvious to us and not obvious to them. So the fact that they can't do that makes me think they need to learn.
The explanation doesn't come from the data, but has to be proposed and then tested against the data. Thinking about the role of the scientific community in checking and scrutinising claims, and then relating this to the technological applications, looking at risk and comparing the risk with the benefits we get from an activity as a means of judging it, and looking at how decisions are taken both individually and by society as a whole about whether we should or should not use some of the applications of science and technology which are now available. It's important for students to have opportunities to practice reasoning and developing arguments about scientific matters, and also analysing the arguments of others, partly to develop the skills of careful and close argument using data, making sure your reasoning is tight and consistent, but also feeling licensed, entitled to engage with that kind of material, not feeling that it's something for other people which you can't engage in. So the course develops and provides opportunities to practice many communication skills which will be useful to students in studying other subjects and in whatever they do beyond the course.
Old GCSE had a tendency to be where you just spoon-fed lots of content, then they get to A-level and they find it very, very difficult to become independent learners. And in this instance, because of this new GCSE course, yes, they have to learn content still, and they do have to learn that, but because they have to do lots of situations, lots of tasks, lots of times in lessons where they have to just think independently for themselves and work as part of a group and come up with ideas as part of a group. And and do discussions and have an opinion and formulate opinions. This is the sort of skills that they need at A-level, and so hopefully when they do move over this current year 11 into year 12, we'll be able to see that come through.